What's going on, guys? It's the Unhinged Engineer back with episode 5 of my grad school vlog. So if this is your first episode, welcome. I'm going to grad school at night studying computer science at Georgia Tech while I work my full-time job in software engineering. And I am about a month into my first class, which is AI Techniques for Robotics. So I've been super excited about this course since before I even started the program. It's a core requirement for me. And I've been loving it so far. So last episode, I concluded the first project, which was on Kalman filtering. So it was pretty cool. I feel like I got a lot from it. And that was something that I'd always wanted to study, but never had an opportunity to. And this assignment asked us to implement it from scratch within a pretty interesting problem that they came up with. So that was cool. But this week was a bit of a lull. I was also traveling for work, so I kind of deprioritized school a little bit. But what I mainly focused on at the beginning while I was traveling was the extra credit assignments that they give us. I always appreciate extra credit from professors, and we were able to get a max of 2% extra credit by doing certain assignments, which I'll tell you about in a moment. But after I completed those towards the beginning of the week, I watched lectures for particle filters and also kinematics of bicycle motion. And if that sounds like out of left field, that's because it was. I'll talk about both those things more in depth when I discuss the particle filter project and the midterm exam, respectively. But I'll touch on them a little bit now because I did watch the lectures for the first time recently, and I just completed the problem set, which, to be honest, at this point, I'm not getting a ton of value out of the problem sets, but I did complete it, so it's worth discussing. So enough beating around the bush, just get right into it. So starting off with the extra credit assignments, there were two kinds of flavors that you could do. One was research challenges, which involved reading a research paper on a topic we learned in class and then summarizing for everybody, standard discussion post stuff. And then the other one was hardware challenges, which involved actually acquiring some robotics hardware and discussing it briefly. Again, standard discussion board stuff. You could either do all of the research challenges, all of the hardware challenges, or half of each. And I went with that. Because with the hardware challenges, they're all very easy, and then the last one was a huge ramp up in difficulty for some reason. Same thing kind of went for the research challenges because, the topics get more and more complex. So I was let me just do the easy stuff, bang it all out during this weird interim between the two projects that I have. So for the research challenges, I read one paper on Kalman filtering, specifically on accelerating the Kalman filter with a GPU. And that was pretty cool because I work with GPUs all the time at work. And that's mostly in an AI ML context, but it was neat to see GPU acceleration techniques that I'm familiar with from work applied to traditional state estimation control system stuff, which is what my background is traditionally in. So that was pretty neat. The other paper I read was about expanding the particle filter to track multiple objects, even behind occlusions, right? So if a person would walk behind a wall, they could propagate the motion from the start of the occlusion to the end and then kind of pick it up on the other side. Effectively, it was giving the particle some object permanence, as well as attributing each particle to a specific entity if there were multiple, right? If you're trying to track multiple people.
Hi, well-rested Unhinged Engineer here. I don't know what happened last night, but things got super choppy. Basically, I was talking about particle filtering for multiple objects. So they use this additional Bayesian technique to augment the normal particle filter and allow it to track multiple objects and track things behind walls, which is pretty cool. I didn't really understand that one as much as I understood the GPU stuff because I work with those a lot, but I understood enough to write the summary, so that's what I did. As for the hardware challenges, I primarily wrote about my Hawkswork F450 drone kit. Once I put more autonomous stuff on it, like computer vision or SLAM or whatnot, I'm definitely gonna make videos of this drone. But for right now, it's just a manual flight drone that kit that I assembled and probably paid too much money for. So I talked about the PX4 in the post because that's the thing that runs the firmware that spins the motors, and I just kind of thought it would be easy to describe. That was the first hardware challenge, and then the second one was actuating your environment. And one example of that they provided was a drone flying around, which I feel like is a lame example of actuating your environment, but oh well. Either way, I used an old video of me and my buddy flying this thing around and made sure there's no swearing in it before I put it on edX. And just talked about how propellers work. So that wasn't exactly a heavy lift. But extra credit's always nice when they offer it. And hopefully I don't need it, but if I do, it's there. So that's the extra credit. And now jumping back to last night's recording, I'll be talking about the particle filtering and kinematics of bicycle motion lectures. I'll definitely talk more in detail about particle filtering next week, but yeah, just a little prelude.
For right now, I enjoyed it. It's definitely less familiar to me than the Kalman filter, because I know the Kalman filter is a lot more history and relationship to like control systems, and that's what I focused on before. And so like it was all the linear algebra and some of the assumptions that they ask you to make were very familiar to me, and were not like leaps to the imagination at all. And then the particle filter, by contrast, seems like totally different. I have used like particle methods in like particle iterative methods, which has a application orbital mechanics that I've used before, but that was like kind of basic, and we didn't use it for very long because it was like slow as shit. But I've never done like state estimation with particle filtering before, so it definitely seems like a very different paradigm. So yeah, that'll take a little bit longer to wrap my head around, even though the lectures went in pretty good detail, I think. The main thing that's kind of lost on me right now is the resampling procedure. That's interesting. So I gotta chew on that more. But anyway, as for the kinematics of bicycle motion, it was like super out of left field. I honestly checked whether it was in anything, because if it wasn't, I probably wouldn't have watched the lectures. It is on the midterm, so I kind of was like, okay, fine, I guess I have to watch these. The bicycle motion thing is supposed to be like an approximation of a car, which I guess was them trying to tie it back to the central gimmick, theme of the course, which is full self-driving. But yeah, a car obviously has 4 wheels, but you can like approximate the front and rear axle as one wheel and then draw like a center line through. And then if you describe like a distance that you travel at a certain steering angle, then, you can get like a, radius of the turn. And it's just like a bunch of geometry. Like I didn't really understand what the point of this all was. And the particle filter project is about like the solar system. It's not about bicycles at all. I didn't really get it. I think they were trying to kind of like bring some physics into the course, which honestly I appreciate. So if that was the goal, then, kudos to them. But yeah, for right now, it doesn't really make a lot of sense. It doesn't really line up with the rest of the material. But, it wasn't too difficult. I just kind of got through it. And then for the problem sets, it was just kind of implementing the stuff that they discuss in the lectures on your own. The majority of them I was able to get first try. Not first try, but able to get on my own without like substantial help from solutions or lecture videos or whatnot. Yeah, nothing's really first try in coding, at least for me. If it is for any of y'all, then you're cracked. But yeah, so most of those I was able to get on my own, but then a couple I had to like look at the solutions and make code citations and stuff like that. But yeah, the problem sets are pretty straightforward. I think the projects are where the main learning and banging your head on the wall come in. Which I just started today. So hopefully next week I have more progress to talk about on the project. But yeah, sorry if this one sounded a bit like a ramble. It kind of was. I was just like rambling about the different topics and trying to bang out some of the low-hanging fruit before I pick up a head of steam with this next project, which I'm going to start now. So yeah, we'll talk about that next week. Thanks a lot for watching. I'm the Unhinged Engineer. If you're working in software engineering, autonomous vehicles, AI/ML, like aerospace and defense, thank you. If you're working in one of those industries and you want content from somebody who's trying to work on that kind of technology too, this is the channel for you. I make both technical stuff and non-technical stuff about career development because I think they're both super important. And then I also am vlogging my grad school journey. This is the 5th episode of that journey. And yeah, if you're interested in that process of going to school at night while I work full time, then this is also the channel for you. I hope you enjoyed. Thank you so much for watching. I will see you in the next episode. Please like, comment, subscribe. God, I am tired. You can probably tell I traveled this week. I will see you next episode. Thanks.